Hey everybody, I'm Nick. We're going to get started in a couple minutes, so if people want to take their seats, we can get started on time. It'd be awesome. Thank you very much.
No problem. Yeah, it's always really? I'm just kidding. Yeah, sure. Good. I see he's up here. to make better infrastructure than you would ever do. You see what I'm saying? So, parse, backend as a service. So, like database, validations, etc. Yeah, so you just set up this graph, and they give you named database. And then you'll scale. It's automated, but it's just these graphs. Am I correctly saying?
Yeah. But all the things I've read online,
Is this the, yeah, this is like the Classcraft.
Matt and I are talking about this game or they like the idea of scale is there are multiple levels of scale.
Perhaps, yeah.
So there's
keep going. That's what Periscope is.
like 10, okay, it's like 10,000 users. That sounds good. When you're talking
Hi, everybody. I think we're going to get started here. Thank you, everybody, so much for coming to our very first Meteor Night. Thank you very much for coming. Yeah. I'm your MC for the evening. My name is Nick Coe, and I work on the community side of things here at Meteor Development Group. We've got a really great lineup of talks for you guys tonight. So let me quickly take care of some housekeeping so we can get underway with those. If you're joining online, you should click live to sync up with the live stream. Makes sense. You can submit questions for our speakers if you're remote by tweeting them using hashtag MeteorNight. I'll keep an eye on the hashtag and ask any questions that you've got if you couldn't make it to San Francisco tonight. There's about 20 seconds of lag on the video, just for your awareness, or if I seem slow on the uptake. And with that, I will introduce our first speaker of the night. Our first featured talk tonight is from Shawn Young. Shawn is co-founder and CEO of Classcraft, a platform that helps teachers manage, motivate, and engage their students by transforming their classroom into a role-playing game. Since its launch in August 2014, Classcraft has gained incredible traction with educators worldwide. With a unique background in physics, education, gamification, and web development, Shawn's interested in how we can create community in the classroom and how games can make learning fun and interactive. Shawn taught 11th grade physics for 9 years, got a little experience, where he implemented innovative approaches such as a flipped classroom, project-based and game-based learning. He holds a bachelor's degree in physics and a master's in education from Sherbrooke University. Shawn's also a seasoned web developer, working for clients such as Chanel, the Future of Storytelling Summit, Carnaval de Sherbrooke, Heido Quebec, and the Feast Social Innovation. He's also had speaking engagements across North America and Europe. At Classcraft, he leads product development, education, and game design, leading the development team and building out the tech that drives the game, designing new features, and coordinating educational research projects. And tonight, Shawn will tell us about scaling Classcraft. So, everybody, without further ado, please welcome Shawn.
Thanks, Nick. Hi, everybody. Welcome to Meteor Night. My name is Shawn Young, as Nick said. Tonight, I'm going to talk to you about Classcraft, what it is, and how we scaled to 600,000 users in the last 18 months, and some of what our challenges have been in terms of stack, and how moving to Galaxy has really helped us do that. So just to give you a bit of an overview, Classcraft is a free online platform that transforms any classroom into an immersive RPG. It's all built in Meteor. We have native web apps, native iOS and Android apps, and with a backend that's all driven by Meteor. We'll go a bit into what the app is a little later, but it basically has a very interesting scaling demands because one user, one teacher, it actually generates 100, 150 students. So for each user that comes on board, we're actually driving several hundred new users as well that all have similar usage patterns. So just to give you a bit of an overview, I founded Classcraft with my brother Devin here in the center and our dad, Lauren Young. Devin is the creative director for Classcraft, and Lauren does admin. We found the company in 2013, at the end of 2013, but we launched our official product 18 months ago. So 6 months from founding the company to having an up-and-coming startup in education. We're based in Canada, but we also have a satellite office in New York City. So it started out the 3 of us. We're now 10 full-time staff. Our pricing model is a SaaS, so there's a free version with a premium version for added features at $12 a month. And we just closed up our seed round today for thanks. For 1.5 million in funding. So yeah, so this has been our traction. Kind of started off slow, and now we're up at just shy of 600,000 users. We're across the world in 75 countries. We're translated in 8 languages. And it's been growing a lot since the fall. We doubled our users just at the time we were moving to Galaxy. So this is about when we moved to Galaxy. So we were already at that time on our old stack, putting a lot of energy in maintaining that. And tonight I'm going to talk to you about how moving over to Galaxy solved a lot of those issues at a critical time for us, where we basically were doubling our number of users. So just to give you a bit of a vision of what our traffic looks like, it's related to classroom usage. So we have people using it during the day very intensively, and then it dies off during the night and during the weekends. Very long session lengths as well. We'll have people who stay connected for an hour, for 2 hours, teachers with their students. And right now we're running something like 5,000 concurrent users at any given time, but it also spikes during the day. We can go up to 10,000 users. So intensive traffic at the same time during the day, but it's also a fairly complex app as well. So just to give you a sense, I'm going to just switch over here and show you a bit of what's going on. Basically, this is a teacher dashboard. Kids play in teams all year, and the goal for them is to gain great powers. So powers like being able to use their iPod during class time, or being able to eat in class, hand in an assignment a day late, real life benefits for them as learners. And the way they get those powers is the teacher gives them points for good behavior. So as they evolve through the classroom throughout the day, the teacher will give them points and they'll level up. They're also playing in teams, and if they do bad behavior, they can lose hit points and they can eventually fall in battle. So there's a lot of interaction going on between these users. So for example, this player could use his healing power on this player, heal her up, give her some HP. And so what we have is a lot of reads and writes between different users, all going on at the same time. For a group of users for a classroom, they'll all be logged in at the same time, using powers on each other. So very intensive app usage. There's also a lot of other stuff in here to complexify this even further. There's full-blown messaging. We have a place where teachers can put resources and users can comment it. So there's an actual discussions that are happening. We also aggregate data across the entire game experience. So we can build research reports for teachers that they can show to parents. So this is pretty interesting because we're aggregating here thousands and thousands of data points of things that happened in the game. And we have an aggregate for the player, but we also have an aggregate for his class. And we also have information on which ones come out more often for 3 different metrics. So there's some pretty intense lifting here happening, and it's happening pretty quickly, as you can see. This specific collection has over 25 million data points right now. It's the collection of everything that happens in the game, all the game logs. So there's a lot going on. Kids can also customize their characters, and as they level up, get cooler and cooler characters and customize them piece by piece. So a lot of interaction between users. And so we not only have a lot of traffic, but we have a lot of complexity as well. So when we first launched this, there weren't that many turnkey solutions for hosting Meteor apps. So we were running off of AWS. Obviously, we wanted to scale vertically, so we started using Passenger, which is a a tool that allows us to basically create different app instances across processes. So at the end here, we had a very large single server, had 16 virtual CPUs with 2 app instances each. So that single server was running 32 instances of the same app. And it was working okay, but we were having a lot of issues as we were scaling so fast. So it was a lot of config to do. Load balancing was very tricky because we were load balancing across processes, and sticky sessions were kind of high. We needed sticky sessions, but we also needed to load balance, and it was creating a lot of conflicts between those two desires between each other. And at the same time, when we would deploy, it was pretty imperfect in terms of actually allocating users to the right processes, and then they would be on the wrong process, and because of sticky sessions, keep going to those processes. So we were having relatively serious memory issues, and because it was all on the same server, it was actually affecting our entire user base. So things with Galaxy are pretty different. The way Galaxy works is that you have separate containers. So each one is an allocated single app server that has 1 gig of memory, and basically it runs your app on that single container. And what you do is you have multiple containers, so it scales horizontally, and you can scale at will. And of course, in very Meteor style, they built it so it was no config, super easy to scale. And then there's a whole bunch of slew of features that are part of that that really answered a lot of the problems we were having. So I just want to go through some of those with you. One of the things that's really core about Galaxy is how easy it is to scale. Basically, you can spin up a new container instantly just with the press of a button, or scale up and scale down, depending on your needs. And then the load balancing in Galaxy works really well. So it will, if you provision new containers, it will then allocate new users to those containers. So as you get traffic spikes, you can scale up and allocate your new users to app containers that don't have anybody on them. You also get like this ongoing panel to tell you how many people are connected and where they're connected. So it scales really easily, but for it to properly allocate users, you also need something that's really core to that deploy process. So you're deploying code, but you don't want to disconnect everybody at the same time. What we were doing with our old app server was when we would deploy code, everybody would get disconnected. And then the server would spin up new processes and allocate people to those processes. And there was an issue there because as it was spinning up processes, maybe it would just spin up a couple, 3, and then users would start trying to connect, and they would all connect to the same 3 or 4 processes. And then the 30 other ones didn't have anybody going to them because they were now stuck on sticky sessions to these specific processes. And the way that Galaxy handles that is when you do a deploy, it'll spin up a new container. So it spins up a new container, then moves users from one container to the other container, then destroys the old container, which has the old code, and then progressively does that for each container. So these are rolling restarts, but they're really important because what it means is a few things. The first thing it means is that your users don't get all disconnected at the same time. The second thing it means is that it's a lot easier on the database. One of the things we had when we would deploy on the old app stack was everybody trying to reconnect at the same time would cause like serious pressure on the op log on the MongoDB. So now what's happening is that because it's happening progressively, all those watchers aren't happening at the same time. And that really means that you can deploy during the day as opposed to waiting till there's nobody on the app. Another important thing is that it load balances properly across containers. So it'll look at which containers are being used and properly allocate users, as you would expect. But it also handles sticky sessions. So sticky sessions are the idea that you need process persistence. And that's really important because identity stuff of the user is carried over to the session server side. And if a user gets disconnected, you want to make sure that you're able to have them maintain a stateful connection. So if you have a single app single screen app, for example, like we do, you want to make sure that if there's a delay in connection, or if they're using long polling as opposed to a proper WebSocket, that they'll always be connected to the same server, so that they maintain persistence of their session. So the idea is that if users get disconnected, they will go back to the same container where they were originally. So they're always connected to the same server. Another important thing about Galaxy, this is from the Galaxy dashboard, and this is, for us, was also critical. We were having, specific memory issues across specific processes, but it was affecting everybody. In Galaxy, we have isolated memory management. So what that means is we can control it on a container level, see where it's spiking, so that we can then see what's going on within that specific container and see where memory is being drawn. We can also see logs for that specific container as well, and we can also kill the container completely if we need to. And what that means is it allows us to delve a lot deeper in terms of, because you're scaling across 50 containers, for example, but they're not all doing the same thing at the same time because the users aren't doing the same things. And with this, what you're able to do is see what's going on in a specific instance and get very deep down in terms of managing your memory. It also means that if one of the containers spikes, or if there's a memory leak, it's not going to affect your entire user base. It's just going to affect the ones that are on your container. And Galaxy's pretty smart. If your memory starts going over the recommended limit, like if you go over a gig of memory usage, it will spin up a new container. So it'll spin up a new container, move your users that are experiencing degradation to the new container so that they don't have lag for extended periods of time if you have memory issues. So very important for us. It also has integrated plug-and-play SSL, so no setup there either. And it has single-line deployment. Now, we had single-line deployment in our other stack. We had built our own deployment with Capistrano, which is a Ruby tool. It was good because we could just deploy. On the other hand, it was really annoying because we had to handle the whole build process of Meteor. So we had to build, our own tarballs, upload them, untar them on the server, start the app, and it was a little heavy, especially as Meteor evolved. We kept having to go back to this script and evolve it. So it was pretty heavy. It also didn't have user management, which I didn't realize we needed until we started scaling the team. Basically, anybody on the team could just type that and deploy straight to production. So I love my dev team and I trust them, but you want to make sure that you have proper access. So Galaxy has all that. So it has it tells you who deployed and when. It also has a single line deploy process. You don't have to configure it, which is nice. And it has user roles. You can it's related to Meteor dev accounts. So you can assign permission to specific Meteor developers to have access to your deployment process. So it means that you can make sure that not anybody can just call that if they have access to your code base. And again, no config. So the last part of the stack is the database, and this part is not part of Galaxy. This is just what we've been using since the beginning. We used a marketplace Mongo instance from AWS. They don't have it anymore, unfortunately. So it was great then because we just spun up this Mongo instance pretty quickly and we were able to use it. We have a fairly large DB right now, and it's still going strong. So it's a little annoying because we can't. Galaxy is not a one-stop solution, but in terms of the app server, it really is. So there's a few things that would be great to have in Galaxy. It's not all perfect. One of them is better monitoring tools, and I know that MDG is working on that, but we do still use Kadira for a lot of monitoring. And Kadira is great, but it's an external service, so it'd be nice to have that at the server level to be able to monitor what's going on with your apps in a better way. And then it's again, it's not a single standalone solution because you have to have a separate DB server, and you also, like for us, we have a lot of helper tasks on a little server that runs, cron jobs and cleanup tasks and stuff. So you can't just only have Galaxy. But I'm pretty confident that their vision is to make it a more of a one-stop solution. But right now, in terms of like the app process, it's pretty solid. So just to give you an idea, before we were spending something like 10 hours of dev time a week on sysadmin, and sometimes way more than that if we had scaling issues. At the moment where we moved over to Galaxy, I was spending like 30 hours a week debugging servers. And so, sysadmin is very cost prohibitive, takes a lot of time, and I don't know, I'm not the type of developer who likes doing that. And no joke, now we're putting 0 hours into sysadmin. Literally 0. I haven't done any sysadmin since September. So I think that in itself is a testament of how solid it is and how well it works in the Meteor ecosystem. I think as well, like as we build apps, what we want to be focusing on is not sysadmin, but building rich products and meeting our users with what they need, as opposed to working in SSH, tweaking servers. So for us, this was a real boon, and it made it a no-brainer to switch over. And I think that a lot of developers would see it that way as well. So for us, what's next is we're going to be integrating with different partners. Google Education has a nice, large teacher user base, so we're going to be looking at integrating with them. We're also going to be building out an API. Hopefully, we'll have reactive endpoints. And then more game features to make sure that kids stay engaged. So that's it for us. If you want to find out more, you have our website, our email. Thanks for listening.
Questions for Shawn?
Yeah.
How much does it cost you to run this service?
Well, we paid for, I don't know if we have a standard package. We were part of the original few companies that were there, and we paid up front for the whole year. But right now we're paying something like $1,500 a month.
Could you repeat the question, Shawn?
The question was, how much does it cost for what we have? So we have a fair amount of containers. I think most companies would have less containers than that because it's a very complex app in terms of user interactions. So I'm pretty sure it could be a lot lower than that for other people. But I mean, for us, just the dev time we're saving justifies it, the difference. We were paying on AWS for our single server something like $850 or $900. So, yeah.
Did you also consider other Mongo hosted solutions like MongoDB or part of the Galaxy itself or something like that?
We did look at other Mongo instance services. The question was, did we look at other Mongo possibilities for hosting our DB than AWS? We do have our staging services, our staging app. The DB is on Compose. We didn't feel the need to look for other solutions because right now it's just chugging along fine. I think as we scale, we may have to, and then we'll check it out. But for now, we didn't need to, so we didn't do it. Yeah.
Yeah, I'm curious if you have a sort of a broad number of containers and they're upgrading their code at different times or in sequence. At some points, you're going to have two sets of code.
Yeah.
Do you ever run into issues with the database, different styles of data store? Because of that, your business rules might be conflicting, or is that not an issue?
The whole deploy process across 50 containers lasts like 3 or 4 minutes.
Okay.
So it's not like this thing where for a few hours you have conflicting code versions.
Sure.
So we haven't really seen any issues there.
Okay. Nice.
The question was, as the code rolls out in rolling restarts, do you see problems with having conflictual code?
Other questions for Shawn?
Yeah.
How many times per day do you push code?
That depends.
What's the question?
the question is, how many times per day do we deploy code? Usually like once per day. We'll try and make sure that it all happens like when there's the least amount of users. Because even if you have rolling restarts and everything, you still want to like minimize as much as possible downtime. So we'll do that, around midnight type of thing. But sometimes we've done it like 3 or 4 times in a day if we had severe bugs we needed to fix, and it was not an issue. Yeah.
Sorry, do you do staging before you actually deploy?
Do we do staging before we actually deploy? Yes and no. We'll do like hot fixes and just put them right into production, and just like if it's one line of code. If we're doing large feature rollouts, then yeah, we'll push it to our staging server, and then test it out, and then push it over to the production. Our staging server is on Galaxy as well. Like when you pay, you get a fixed number of containers, and you can spread that across multiple apps. So you could typically run 3 or 4 apps if you wanted on your single subscription. So what we have is the staging server has like a couple of containers, and it's just so we can test stuff. Yeah?
Yeah, do you guys plan on having like different game themes in the future, like for different age groups, or is that mostly just focused on this right now?
So the question is about the product. It's do we plan on having different game themes? Yes and no. Yes, we do. Not soon, because it's actually so we have somebody working full time just drawing these characters, and it's actually a lot of work, especially if you want to keep up this level of like detail and quality. Like this is, looks like a real video game, and when going to students, that's really important. When you say, oh, we're going to turn class into a video game, if it doesn't look like a video game, then they'll be like, yeah, whatever. So the short answer is yes, we would love to do that. Especially, we could easily like swap this out for like a sci-fi type of theme, or a more young child friendly type of theme. But right now we're still fleshing this one out.
We've got time for one more question.
Who raised their hand first? Okay.
How many concurrent users are you getting per container?
So we have like an average of like 50 or 60 containers running, and we'll typically go from 5,000 to 10,000 concurrent users. So we're talking like 100 to 200 concurrent users per container. The question was how many concurrent users per container? Yeah.
What's the age range of a user? What's the normal average?
So the question is, what's the age range of our users? Actually, the game is really customizable. So we have people using it from grade 3 all the way up to college classes. We also have enterprise level people using it in their company to gamify their staff. We have people using it at home with their kids, because you can customize all these rules, why you gain points, what the powers are. Typically in K to 12, the average age is 14, but there's like a huge like curve around that.
All right. Excellent. Thank you very much, Shawn.
Thank you so much. I'll be around if you have other questions.
All right. We'll keep things moving along here. So our second featured talk for tonight is from Mike Rissy and Jeff Ware. Jeff uses good code and good coffee to build a great user experience. He graduated from the Masters in Computer Science program at Stanford. I've heard of it, with a focus in HCI, and works as a full stack engineer at Mixmax, where he's building Slack for external communication. Mike is a freelance Meteor developer currently building a restaurant inventory management system. He's worked on many Meteor projects over the years, including Mad-Eye, Velocity, and MeteorPad. Also, coincidentally, Mike and I went to college in the same small town in Minnesota. So tonight, Jeff and Mike will be presenting about building Mixmax for OS X using Meteor and Electron. So everybody, please welcome Mike and Jeff.
Hi, everyone. I'm Jeff Ware. I'm an engineer at Mixmax.
And my name is Mike Chrissy. Today we're going to talk about a project that we've been working on together called Meteor Electron. But first, what is Meteor? I assume you all know, but Meteor gives you a radically simpler way to build real-time mobile and web apps, entirely in JavaScript from one code base. Is it just me, or is there some kind of app that's missing there? Electron lets you build cross-platform desktop apps with web technologies. Oh, that's right, it was desktop apps. So quick overview of what we're going to be covering today. First, we're going to take the to-dos demo and show you what that looks like in Electron. Then I'm going to hand it over to Jeff, who's going to talk about how they took Meteor Electron and used it to do a real production thing, and in the process made it a package that can handle a lot of the demands of production, essentially taking it from a toy project to something that is ready for use. So without further ado, let's see a demo. So this probably looks familiar to you. This is your normal to-dos app in Meteor. And there's nothing fancy going on here. This is just a completely normal to-dos app. And I'm going to type one command here, Meteor add Meson Electron. OK, so I added the package. The app server is restarting. Now it's building the Electron app, and there it is. So now we have a desktop app running Meteor. So one of the super important goals for us on this project was making it super easy to do this, and I hope we succeeded. But we wanted to do more than that. We wanted to be sure that it was also easy to do something more advanced than just a simple wrapper. And provided you're not doing anything too fancy, you should be able to do this mostly with a declarative configuration. So now I'm going to copy this into my settings JSON file. Press save. And the app is going to be rebuilt. And there it is. I don't think you want to make a window that size, but you can if you want. And there's lots of other options that you can configure there. You can change the name, the icon. If you're interested in what you can change in this way, check out the GitHub page. All right, so getting back to the presentation now. I wanted to give a few of the reasons for why we built this package. And one of them is that we think Electron support should be easy. Honestly, it's not that hard right now. You can do it yourself if you have a day or two. But we like to think that we made it easier. We also wanted to provide a collection of best practices from dev to production. So I hope you see that it's like a pretty nice environment for developing. Changes to the native Electron app as well as the Meteor app will hot reload for you while you're developing. And one of the other requirements of the project for us was that it be a thin client approach. So there's a few other Electron packages out there, but they've all taken a thick client approach, I guess, in that they've bundled the Meteor server into the application. And that's great if you need offline support, but we didn't, and we wanted people to be able to collaborate, which requires a central server. So when I say thin client, this is what I mean. The Electron app, as well as the web browser, are all talking to one Meteor web server. At this point, I'm going to hand it over to Jeff, and he's going to talk about how this can be used for something a little bit more demanding than a to-dos app. Jeff?
Thanks, Mike. So as Nick said during the introduction, I work for Mixmax, which is building a rich communications platform that is like Slack for external communication. So we bring the same visibility to your email that Slack does to your chats, as seen here in our live feed. So this is a feed of all the interactions that people are having with their email, if they're opening it, if they're clicking links in it, if they're downloading files. And this feed is so powerful that our users wanted to keep it open all the time, which is why we wanted to make a desktop app. And as Mike showed earlier, what attracted us to Meteor Electron was that it's so easy to convert this web app into a desktop app all we had to do to get it running in this wrapper was just simply add the package to our application. From that point, it was really easy to make it start looking more like a desktop app by changing that settings file that Mike showed. So to get it loading the right URL to start, we just had to set the root URL and the launch path to be appended to that. To change the app icon, just had to provide a path to the file. And to hide the title bar, again, just another settings change. And we made it possible for changes to the settings file to reactively reload and relaunch the application. So even though Electron is adding another layer to your app, you have the web app as normal, but then it's loading in a native shell, you still get the same convenience you're used to with Meteor. So that's really the first feature of Meteor Electron, is that it allows you to easily iterate on a native app, just as you would with a web app. Some of the changes that we wanted to make when going from the web to the desktop couldn't just be declared in settings or accomplished merely through responsive CSS. Some changes required using Electron's native APIs. Now here's one example of how you might do that in Electron. Let's say that you want to open a URL in the browser. And if you simply call window.open in Electron, it'll open an Electron window. You have to call this node API to open that URL in the browser. And by default in Electron, you can actually use all of Node's APIs, all of Electron's APIs from the browser. So you can require this module and call the method that opens it in the browser. But if you just use Electron APIs willy-nilly, you can end up exposing things that you might not want to, like the ability to delete the contents of your hard drive. Electron expects that your HTML and CSS and JavaScript are running locally, so it treats them as a trusted extension of the native code. This is not at all a good assumption when running a hybrid web app, as we are in using this thin client Meteor Electron approach. So what we need is some sort of native bridge where it's possible for the web to access Electron APIs, native APIs, in a trusted fashion. So what we do is we make this Electron module, and it's possible for that to define select APIs that under the hood use Electron's native APIs, but you can no longer just require whatever you want and use those insecure APIs. The details of how we do this are out of scope for this presentation, but if you're curious, I encourage you to visit our blog as given in the URL there, and you can find the technical details there. And I should say that this presentation will be posted to the meetup group after the talk, so don't worry about remembering these things right now. Now you might ask, what's bridged? And currently, the only APIs we bridge are that URL opening API, an accessor to check if the app is running in full screen or not, and an accessor to see when it transitions between full screen or not window events. And this is not a lot. We're not bridging APIs to create menu bar items, to show desktop notifications, all the good stuff that Electron provides intentionally. The native bridge is meant to support web apps so that you can very quickly make your web app look and behave like a native app with minimal code and in a safe fashion. If you want to go beyond that to make a super rich Electron app, for instance, the Mixmax application shows an icon on the menu bar, it's totally possible to swap Meteor Electron's default application code out for your own. You just give it the path to the directory where that code is. And it can still integrate with the rest of Meteor Electron. If you put that code in the private directory, you can still get reloading as Meteor would do. This is a totally anticipated use case, and there's more directions about how to get that set up on our blog. On the README. So now you've seen how Meteor Electron reactively rebuilds your application, and it gives you this runtime support, this native bridge. It also supports serving your application's downloads and update feed. That's right, as a Meteor package, it can totally just add middleware to your server without you having to write any of that code yourself. So one of the things it does is allow you to tell it where users can download your app. So if you put the URL to a zip file in your settings, the package will just start serving that from your application's root URL plus /app/download, and then the platform is Darwin or Win32. It's not rocket science, this redirection, but it's necessary. So this is one of the things that Meteor Electron does, is Meteor Electron takes care of the unglamorous tasks for you, so you can get very quickly from started with Electron to shipping a production app. You might ask, what are we downloading? And the question you need to ask yourself is, do you want automatic updates or not? This might seem like a gimme. Of course you'd want automatic updates. But there might be situations where you're fine shipping individual builds. If you're at a hackathon, for instance, or if you're shipping internal builds for beta testers. And we mention this because it's much easier to do this than to set up automatic updates. If you want to just ship individual builds, you just need to enable auto packaging in your settings. And if you want to set up a Windows build, you just have to tell Meteor Electron, again in your settings, that you want to build for Windows as well. And it'll create these builds, and you can just take them from the directory on disk where it creates them, put them at the URL that we showed previously, and you'll be good to go. If you want automatic updates, there's a bit more work that you have to do. For Mac, you have to sign up for Apple's developer program. You'll get a certificate to use to code sign your app. You tell Electron the name of that certificate, and it'll sign it. And again, you have the build. You can upload it to the server. If you want a Windows app, it's a lot more complicated to code sign that application to bypass Windows virus scanners. Just letting you know this up front. So our sort of approach that we've taken with Meteor Electron is that we will provide you as much support as possible to build your desktop app. Everything that can be automated, packaging your application, reactively rebuilding it, serving the download and update feeds, Meteor Electron automates that for you. Things that require configuration, like your application size, the icon, or whatever, Meteor Electron supports configuring those things. And things that require you to set up, like this code signing, it's a one-time setup, Meteor Electron documents in full. And we won't force you to take that step until necessary, until you're ready for it. So that's sort of the approach that we've taken, is give you as much support as is possible and show you what you need to do when you need to do it. An example of how Meteor Electron can gracefully upgrade from the hobbyist use case to the professional use case is these download URLs. So if you're just, want to make it easy for your self-serving, you can put those builds in your Meteor Apps public folder, and they'll just be served from your root. And you can get a permalink to that just by having a single link to that build. But if you want a more efficient setup, a bit more complicated but a bit more performant setup, you could use something like CloudFront and have version URLs, set up caching for that. And if you just put a placeholder in the URL, as you can see there, Meteor Electron will substitute in the current version when you deploy your server. So that's just an example of how we anticipate your needs growing as you get further along with your Electron development. Now I'd like to hand it back to Mike, so Mike can talk some more about the approach we've taken with Meteor Electron.
Yeah, so just to kind of summarize some of what Jeff was getting at, he showed a lot of options, but we want to just stress that it's easy to just build an app and give it to other people. If that's all you want to do, you should just be able to add the package and send people a zip file. And you should even be able to go to the next stage pretty easily. And it's not until you need to do these things like code signing and automatic updates that it's going to be a little bit more involved. And even for that, we hope that it's easier than it would be without Meteor Electron.
Cool. And we wanted to close by saying, by explaining why use Meteor Electron to develop an Electron app in general, and why use Meteor to develop an Electron app in general. And that's because, as we've showed you tonight, developing an Electron app requires implementing changes across 3 different areas: across your build process to reactively rebuild and package that app, at runtime to provide a native bridge to the client, and on your server to serve the download and update feeds. And it seems like a lot of work that all needs to be coordinated by some sort of settings file, but Meteor Electron, as a Meteor package, full stack package, can hook into all of those areas and make the experience as seamless as it can be for you. So if you've enjoyed hearing us talk about Meteor Electron, and if solving problems like this intrigues you, I encourage you to come talk to me or Brad or my colleague Spencer. Spencer, raise your hand and say hi. Later tonight. Now I'd like to open the floor to questions. Some possible questions about technical details I skipped over are given on the slides. And the URL to the repo is shown at the bottom there. So you can, of course, find this and find out how you can get started yourself.
What are you wearing around your neck?
So this is sort of
Could you repeat the question, Jeff?
Oh yeah, the question, yes, they give me what am I wearing on my neck? So this answers actually two of the questions here. What does it take to make Windows remote updates work, and also what I'm wearing. And that is actually a physical USB token. If you want to get code signing working for a new Windows app, you're not an existing Windows developer, the only way to shut down Windows virus scanners for good is to verify your organization's identity, and then you get shipped an actual code signing USB token. So you have to plug this into your computer when you want to build the Windows app. Not as convenient as you might hope. But again, we don't force you to take this step up front. We give you a graceful path to doing so, and we document how to get this going when you need to.
Other questions?
Do Electron apps have an offline mode, or they always assume to be online?
So the question was, do Electron apps have an offline mode? Yeah, Electron apps generally work offline. And we don't really support the offline use case too well. They need to point to a server with Meteor Electron. There are people that are pursuing like an approach where Meteor actually runs locally as part of the Electron app. Meteor, I know, is one of them. And they're pretty interesting approaches, but generally with most Meteor apps, I think, they're multi-user and the data is like synchronized, so it doesn't make as much sense to have an offline mode as it would for most Electron apps.
Let's go there.
Is there support for developer tools, like remote Chrome developer tools or something?
It's totally possible to open the Chrome developer tools in the application. Do you want to show that quick? You still have to do
Yeah.
something?
Could you repeat the question?
The question was, is it possible to use the Chrome developer tools that you're used to with the application? And totally. That's one of the things we configure, actually, is it's just Command-Alt-I. Yep. So here's Chrome developer tools, just as you see in the browser, access to the same goodness in Electron. Electron tracks the latest Chrome, and they're pretty good about updating. So whatever cutting edge features you're used to in the browser, you can take advantage of in Electron.
Do you plan to have iOS and Android wrappers as well?
The question is, can Meteor Electron be used for iOS and Android wrappers as well, or do we anticipate that? Electron is a desktop-only technology because it uses desktop Chrome. For iOS and Android, we're pretty interested in looking into Meteor's support for Cordova, and Martin is going to speak about that after us.
Can you build taskbar applications, or how hard is that eventually?
The question is...
the apps stand there near the clock.
Yeah, the question is, can you use Electron to build taskbar applications? And you can totally do that. In fact, I think we dare risk changing the adapter, or do you have Mixmax installed?
Hmm?
Do you have Mixmax installed? Or?
No.
Okay.
Let's change it.
Let's see if we can tempt the demo gods by showing what Mixmax looks like. So Mixmax's Electron app, as you can see, adds an icon to the taskbar, and you can click on that and access your application's features just as you might hope. That's one of those things that Meteor Electron doesn't support out of the box, and that you would switch to using a custom app directory for, as documented in our README.
We got time for one more question.
One more question. Okay.
Can you hook into desktop notifications as well?
Absolutely. Electron, that's one of Electron's APIs. One of those things that is not supported by Meteor Electron out of the box, but you could totally take advantage of if you used a custom app directory.
Can you hook into desktop notifications?
That was the question. Yes. Thanks. All right. Thanks, everyone.
Thanks, guys. All right. So now we've got our third and final featured talk for this evening. And it's from a colleague of mine, Martin Walraven, who's a core developer here at Meteor Development Group. Martin created Meteor iOS, which integrates native iOS apps with the Meteor platform. He began programming at the age of 9 when his mom bought him a second-hand Commodore VIC-20. He worked with emerging web technologies at a small development company and later became caught up in corporate world of enterprise Java. Who among us hasn't, I guess? Teaching technical training courses to developers. While continuing to work on independent projects, he decided to follow some of his other passions. And that led to a bachelor's and master's degree in philosophy and cognitive science from Leiden University, the Netherlands. He also spent a year as an exchange student at UC San Diego, just a few hundred miles south of us. And in recent years, he's taught philosophy to high school students and has worked on a children's television program about philosophy. Tonight, Martin is going to be telling us a little bit more about the improvements to Cordova coming in Meteor 1.3. So everybody, please welcome Martin.
All right, great to be here again. As Nick explained, I'm Martin Walraven. I'm a core developer here at MDG. And for the past couple of months, I've been working on improvements to our Cordova integration. Actually, we released the first beta of this work yesterday. So this is a great time to be talking about some of that work. But before talking about what's new in Cordova, I'd like to take a couple of minutes to talk about what Cordova actually is. As a sort of one-sentence description, you might say that Cordova allows you to package a web app into a native mobile app. And what does that actually look like? Well, a web app usually runs in a web browser. In the Cordova case, that web browser is actually a web view, a view component that is embedded in a native app. So Cordova packages all your assets, your HTML, your CSS, your JavaScript, your usual web technologies that you use to develop a web app, runs those in a web view, and then packages that all together into a native app that you install on your mobile device as usual. But Cordova has more to offer. Like in addition to just packaging your web app into a web view, it actually allows your web app to access certain sort of device native features. There is a fairly vibrant plugin ecosystem for Cordova. Plugins for core plugins for camera access, geolocation, file access, but also third-party plugins for Bluetooth and various accessories and other features. And your web view, JavaScript running in your web view communicates through a part of Cordova called the JavaScript native bridge to plugin code that actually runs in native code. So that's the basic architecture of a Cordova app. What is Cordova? Well, Cordova is an open source project, an Apache open source project. You may also have heard of the name PhoneGap. PhoneGap was a commercial company that was actually acquired by Adobe. At that point, they decided to spin off the open source part into the Cordova project under the Apache umbrella. So PhoneGap is now one of the distributions of Cordova. Other distributions like Ionic also build on the same open source foundation. So Meteor has had an integration with Cordova for a while. And the idea is that, like other integrations, it, as much as possible, integrates Cordova with the rest of the platform. It doesn't require you to use the Cordova commands or even the Cordova configuration files directly, but you simply use the Meteor run command with some extra options. Cordova project creation then happens as part of the build process. There's also the ability to specify plugin dependencies for packages. But one of the most interesting parts, I think, of the integration is the hot code push. Of course, Meteor has hot code push for normal web apps. If you look at a Cordova app, it consists of several parts. Like I said, the plugins consist mostly of native code. And of course, there's the Cordova sort of infrastructure code itself. But one of the parts of your native app is what you might call the asset bundle. And that contains the HTML, CSS, JavaScript, other assets that, in our case, are actually built by Meteor. And what Meteor allows you to do is sort of hot code push updates to your asset bundle and then replace all your assets by a new version. Reloading your app. This works in development, works great in development, but it's also something that is very useful in production because going through an app store process to actually upload new apps and get them accepted into the app store can be a fairly lengthy process, and this allows you to basically circumvent the app store and deploy new versions of your app instantaneously. So how does this work? And what does that mean for the Cordova integration? Well, in a normal Cordova app, so a non-Meteor Cordova app, the web view actually loads assets from the local file system directly on the device. It uses file URLs to download those access those files directly. In the Meteor case, in part because we want to allow you to reliably sort of swap out asset bundles for newer versions, but also for some other reasons, like supporting client-side routing, we actually use our own file serving plugin. And the file serving plugin communicates with the web view over HTTP and serves an asset bundle, the files contained in the asset bundle over HTTP to your web view. So instead of file URLs, we use a regular HTTP URL. In addition to file serving, the plugin is also responsible for the hot code push. And there are some issues with sort of the old Meteor plugin, the pre-Meteor 1.3 version of the plugin. Downloads can be slow and somewhat unreliable. One of the main issues with sort of the plugin design is that faulty versions, which can occur also because of faulty downloads, may actually lead to an app that is completely unresponsive, that's no longer able to actually update to newer versions, versions where the original fault, the original bug may have been corrected. So that requires users to reinstall the app, and that's not a very good user experience. Because of the design of the plugin, and I'll go into a little more detail later, the old version of the Meteor plugin was also incompatible with WKWebView on iOS. So in Meteor 1.3, there are a couple of improvements. One is that we upgrade our dependencies to the most recent versions of Cordova and the supported platforms. The plugin, the file serving and hot code push plugin, has been completely rewritten, much more reliable, much more performant. I'll say more about this later. These two things together allow us to support WKWebView by default, and this should greatly improve JavaScript performance on iOS. So, a little more detail on the changes. Some of you may be familiar with the old version of the Cordova integration, where the WebView actually connects to a sort of pseudo domain, meteor.local, to download the assets. We've replaced meteor.local with a regular localhost domain for several reasons, but one of the benefits is that localhost is considered a secure origin by browsers, by web views, and that means that they won't block certain sort of security-sensitive features. And the old Meteor plugin didn't actually use an HTTP server, a real web server. Both on iOS and on Android, it uses sort of interception mechanisms, request interception mechanisms. That works fine on Android, but on iOS, NSURL protocol, the interception mechanism, is not supported on WKWebView. So that was one of the reasons for replacing that with a real local web server. The other reason was that there is a sort of great framework available for iOS, GCD web server, a really performant web server. And besides allowing us to support WKWebView, it also offers a bunch of other benefits, much improved caching, support for streaming, and that means we now have a local web server on iOS, but we still use the old should intercept request mechanism on Android. The other change in the new plugin is that we've moved a lot of the functionality from JavaScript to native code. In the old plugin, the web view, the JavaScript running in the web view, would detect that a new version was available through DDP. But it would then also, from JavaScript, actually direct the whole downloading process. So it would download all files using a Cordova plugin, but still sending download requests one by one over the sort of JavaScript native bridge, blocking the main thread in many cases, and also the file transfer plugin, the Cordova file transfer plugin itself had some issues. And then the only task of the Meteor plugin was actually to switch over to the new version when the web view told it that the new version was ready. In the new plugin, the web view is only responsible for notifying the plugin that the new version is available. This is still needed because the DDP connection runs on the web view, and that's where we get the notification of the new version. But from that point onwards, the Meteor plugin in native code is responsible for downloading files using native mechanisms, NSURL session on iOS, and a really great library on Android, OKHTTP. It then notifies the web view when the download is done, and will only switch over to the next reload when the reload actually happens. So this means hot code push is now faster and especially much more reliable. There are a bunch of sort of safety mechanisms built in. We, for instance, validate all assets to make sure we download the right version. We actually compare the hash to the hash in the manifest. Another important improvement is that we only download changed assets. The previous version of the plugin would download all files on every change. That, of course, could be really slow. And we only switch to a new version after page reload. So you never get into a situation where you have an existing web app running that suddenly, when it tries to access assets, gets versions that may be incompatible. So all this means that asset bundles downloaded will be valid. They will be the asset bundles as the server has built them. That being said, there are still situations where that asset bundle, let's say we're now replacing version 2 with version 3, where that asset bundle is actually faulty. There may be JavaScript errors, for instance. So we have an extra safety mechanism that actually listens for the app startup to complete, meaning all callbacks, all Meteor startup callbacks have been executed, and does so on a timeout. So after 10 seconds, if the startup callbacks have not completed, we consider the version faulty. And then we actually revert back to the last known good version, so the last version that did complete the whole startup procedure. If there is no such version, we revert back to the initially bundled version. We also blacklist the faulty version, so we don't attempt to download it again, because otherwise you'd get into a loop. So the Cordova upgrades and the plugin rewrite together allow us to support WKWebView. WKWebView on iOS is a replacement for UI WebView. So this is a view component that displays web content. And UI WebView, due to the sort of iOS security architecture, has an important downside in that it can't use the just-in-time compiler. And the solution for this is WKWebView, which actually runs in a separate process. So that allows it to use the JIT, which means, in many cases, huge performance benefits. There's like WKWebView is available from iOS 8, but on iOS 8, it used to have certain issues. One of those issues was that it couldn't actually load web content from the local file system. This is one of the reasons people haven't upgraded to WKWebView in many cases. For Meteor, because we use a local web server, that's not an issue. So we've decided to enable WKWebView, make it the default on all apps. Cordova, the most recent version of Cordova that we've upgraded to, also requires iOS 8. So that means that WKWebView seems like a safe default. On Android, this is not really a Meteor 1.3 improvement, but something that came out in Meteor 1.2. You can use Crosswalk. Crosswalk is a project that integrates Chromium, sort of the open source basis of the Google Chrome browser, inside your app. It offers a replacement web view on, well, that's especially useful on older Android versions. It's both more performant and is actually more standards compliant, supports newer standards. We have a very simple package that you can add, and that enables Crosswalk. The only downside of using Crosswalk is that the size of your app grows because it embeds Chromium. So that's a trade-off. In many cases, I think it's worth it. And then lastly, something many people have been asking for, Android development on Windows. I feel reasonably secure to say that it's probably coming. Like we have certain platform-specific dependencies in our Cordova code. We already took care of a lot of them. but there were some remaining issues that we just didn't get to. And Stephen Edward from the open source engineering team at Microsoft stepped up, offered to have a look at these issues, and came up with a really great-looking pull request. So I'm hoping to get the pull request into one of the next beta so we can test it more widely. If the results are positive, I think it's something we can get into Meteor 1.3. So for those of you who are interested, it would be great if you could give the beta a try. This is the first beta release that came out yesterday. It's not feature complete. It doesn't have hot code push for Android, for instance. And there are some other missing features. But it would be a great opportunity to get some feedback on this version, especially from people who have existing apps, maybe even production apps. So please give it a try. Respond on GitHub, either to the existing issue or open a new issue if you have specific things you encountered. And with that, I'd like to open the floor for questions.
Questions for Martin?
Yeah.
Is it possible to check scheduled alarms on the phone with the Meteor Cordova?
Is it possible to check scheduled alarms?
Yeah.
I'm not sure about that specifically, but there are Cordova plugins for many features, and if a plugin is not available, you can always write your own. So as long as functionality is available from native code, you can always write a plugin, and in many cases, someone else will have done that. Yeah.
How does hard code, the hard code push protected from DNS attacks such as spoofing or man-in-the-middle, where the client, app is routed to a malicious website because they spoof the DNS so that they go to a different site and then they will inject bad code.
Mm-hmm.
The bad asset, right, into the client.
There's no specific protection mechanism. You could always use an HTTPS connection, I guess. And
Inside the hard code push or because hard code push is not something I can program. It comes with Cordova, right?
yeah. Oh, I'm sorry. The question is whether hot code push offers any support, any protection against DNS spoofing attacks. And I don't know of any specific mechanisms here. This is similar to the situation for normal web apps. I don't think there's anything specific to Cordova. I'm not sure I saw a question there. I think.
Do you have a demo on your computer?
A demo on my computer? Well, I did record a quick demo of our example app, but I don't have anything new to show, no. The improvements in Meteor 1.3 are not features that are immediately visible. They really improve existing apps, but they don't add new features. Sure.
Yeah. By the way, awesome stuff. I was playing with 1.2 and was having trouble, the person was asking earlier about DNS attacks and things like that. But I was having trouble using HTTPS, forcing SSL with Cordova. Is that something we'll be able to do in 1.3?
I'm not actually sure. I think the downloading mechanism definitely supports HTTPS.
There's a long
It's not something I've tested, so if you're interested in this, I would encourage you to open an issue so we can test for this and maybe make the required changes.
Could you repeat the question quickly?
Oh, I'm sorry. The question was about SSL support for hot code push.
We got time for one more question.
All right. I really don't know who was first. I think it was you.
Okay. How granular are the change updates? So if I make changes to 2 of these files, am I going to end up downloading all my packages files?
That's what used to happen with the old version. Now we only download the change files, so it's much more performant. So only actual changes. We also make sure not to copy files on the device unnecessarily. So it's a fairly efficient process.
Could you just repeat that question?
Oh, I'm sorry. The question was whether, like how granular hot code push updates are, whether they will always download old files or only changed files. And the answer is that only changed files will be downloaded.
Thank you very much, Martin.
All right.
Excuse me. All right, everybody. Next up, we have the premiere of our Built with Meteor app showcase. First, we're going to take a 5-minute break. If you're speaking during the showcase, if you could please come backstage now, here to my left. Everyone else, go ahead and stretch your legs, grab a drink, and I'll meet you back here in 5 minutes. Thank you very much.
Good. Good. We have a special Slack channel just for Slack. Oh, it's so
I was like, oh,
yeah. So why don't you want to get in the he's coming back at He's coming back yeah, I guess. Yeah, you were just that's cool. They're all. You'll have a lot of I think we're gonna have like 3 or 4. Interns are a lot of work. Yeah, they are. Yeah. You all are. Yeah. Oh yeah. Hey, good job. That was awesome. Really great. Yo, awesome. So, I need to build a desktop app now, but I don't know what to build. All I have is like my personal website, which is like file. Maybe they can make a desktop. Yeah. Just in case you need to, check that out. Sure. Yeah, you have the updates reactivated. Can you like put those on the Mac app? Thanks. How does that work? Yeah. Should I call you? Yeah. But yeah, I've heard a lot of bad things about that. Yeah, it's bad.
Yeah, that's awesome. Hey, Brad. Nice to meet you. Yeah. So here you all are moving over to Google. Now, after your presentation, I know you all are moving over to Galaxy. Which is cool. We just moved over from modules. Yes. It was pretty interesting to hear that we're all on AWS.
I'm always thinking I should just like
So we were on modules before, and then we just transitioned over to Galaxy. So we're running a lot of experiments on walks right now, because we're running into the few watches.
Now I just
the recent experiments have been pretty successful. They have us now on 2 ACU containers. A bunch of bigger, more vectors. It's turned out pretty well.
okay, yeah.
Hey, Matt.
Yeah. Sorry.
Yeah. So for apps that need NCBO, I think it works out pretty well. You're right, it's kind of funny math, right? Because the 2
Can you update the icon of that taskbar?
There's a lot of
So the UI would be say.
Are you saying or do you have like Redis layer in there at all?
Oh
you're just using Mongo? Okay. So we had to do away with that. So we use Redis. A lot of our applications there. So our app goes over is basically live feed activity inside. Give it a look and see that. But all of that is actually.
Everybody, we're going to get started again in about 1 minute. So if everybody could take their seats, and we'll get started again in about 1 minute. Thank you very much. All right, everybody, we're going to go ahead and get started with our app showcase now. So new this month to Meteor, we've got our Built with Meteor app showcase. Some of you may have heard about this. During this part of Meteor Night, we showcase cool apps from around the Meteor community. And if you're interested in demoing your app at future Meteor Nights, we'll leave a link to the submission form in the description of this video. We've got 3 apps to show you tonight. Talks will be 8 minutes long with a couple of minutes for Q&A at the end. And first up, we have Jamie Loberman. Jamie is the creator of Weighted, which is a mobile app built with Meteor that recommends restaurants based on the tastes and preferences of everyone in your group. So everybody, please welcome Jamie.
Thanks, Nick. Hi, everyone. I'm excited to be here. I'm going to share my thoughts on the mobile UI challenges that we came across while building Weighted with Meteor. And how we overcame them. First things first, what is Weighted? Weighted is a restaurant discovery app, as Nick mentioned. Everything we do revolves around taste, and taste is highly subjective. One person's favorite restaurant is going to be another person's underwhelming experience. So even though that's true, if we were all to open up one of the current restaurant discovery apps, Yelp or Foursquare, or any of the other ones, and we asked it, what's the best restaurant in San Francisco right now, we would all get back exactly the same restaurants, exactly the same list, which means that some of us are guaranteed to have a disappointing experience. So Weighted is the next evolution of this. We take everyone's personal taste into account, who's in the entire dining group. So it's restaurant, and it's based around the premise that restaurant reviews are only really useful if you have similar tastes to the person who's doing the rating. And Weighted solves this problem with what we like to call mapping the taste genome. We connect the dots between like-minded people and create ratings and rankings that are just for you. And this is an interesting technical problem for us to solve because the data is completely real-time, but also completely unique to every single person on the system. So how do we do this? Enter Meteor. And when I first saw Meteor, I knew this is what I wanted to use. I knew this was going to solve all my problems. Meteor's going to do all the reactivity out of the box, and I could just concentrate on building the algorithm. But one thing it doesn't take care of is the UI. And what I'd found was that I had taken a lot of UI in day-to-day apps for granted. And here's an example of that. If we were going to build a clone of the Facebook app or the Twitter app using Meteor, we would build a feed. And a feed is just a list of items. And your users would want to scroll down that list, find something they liked on it, tap on it, digest that information, and then tap to go back. And now, because Cordova is essentially using a glorified web browser to render the UI, what happened was we'd be stuck back at the top of that first page because it's just reloading that first page. And I think you might have seen that when Martin was demonstrating the local market app. What we want to happen is we want to be dumped back at exactly the same point we left that list. And this type of thing happens a lot in mobile UI. You don't really think about it. It just happens. But because we take it for granted and because we're doing things a little bit different here, they just don't happen as easily as we would like. I couldn't find anything that met my needs to take care of this for me, so I started building something called Fast UI. When I looked into it, a lot of people were just caching their position in their long list, moving away from it, and when they came back to it, trying to get back to that position, scrolling to that position really quickly, trying to hope that no one really noticed. That wasn't particularly great, especially when you've got infinite scrolling lists and you're dynamically loading in a load of data, and then you try and come back to it and try and quickly load that data in again. It doesn't really work. So when I built something, I had just two requirements. It needed to be lightning quick, almost native experience, and it needed to take care of a lot of these UI patterns that I wanted to use in weighted for me without me having to think about it. One of the first things that I ever built with Meteor is a package called Transitions. And it was essentially a showcase of the different CSS3 transitions that you could do using Meteor's UI hooks. And I built along with it a little demo that kind of demonstrated what you could do with CSS transitions. And this just hooks into Meteor's as a UI hook, so it's using any router you wanted, and it just hooks in. And when you transition from one route to another, it would add in a little CSS. I got good results from it, so I know I wanted to use it again, or not use it again, use CSS3 transitions again when I built weighted. So using what I'd learned from the transitions package, I started to build weighted. And what we've got here is a list of about 1,000 items, of about 200 items in to the list. I'm tapping on an item, I'm digesting it, viewing it, and I'm going back. And as you can see, it's quick, it's lightning. And what I'm actually doing to achieve this is these two views are not disappearing. The list behind is kept there. The list on the item on front is already there. So it's not trying to load the container in. The content itself sometimes is dynamic, but the actual containers, the two pages, are sliding across each other. And I'm using CSS properties of z-index and display and position to be able to manipulate those, move them off screen, and bring them back in as needed. And one bonus of having the speed of everything ready to go and just off screen or hidden is that you can move them back into place like that. So the iPhone drag to go back interaction that people are used to on native apps, you can implement that. And I haven't implemented this in weighted yet, but I built a little test demo app where you can actually interact with the top screen, have a little peekaboo at what's behind, and if you don't meet your 33% or third threshold, it just snaps back into place. If you do, it completes the transition, and as soon as it completes the transition, it looks into the history and pops the next screen that needs to be behind there back into place. So next time someone goes to swipe, it's ready there. And things like this are just not possible unless everything that you're working with is ready to go and ready to kind of come in. I've put everything that I've ever done with the UI into a demo repo so people can play with it and mess around with it and collaborate on it. There's a link to the transitions package that I created. And then, of course, there's weighted. If you like eating out and discovering new restaurants, check it out.
Questions for Jamie?
I'm curious, do these animations work well? I guess, like, the first question is, are you using the Cordova wrapper, or is this a mobile web app, and do they work well on, like, mobile Safari and Cordova?
Yes, so Weighted is in the App Store right now. It's using a Cordova wrapper. It was 1.2. I did get WKWebView working on. It was a pain, so I'm really excited what Martin had to say, because it's going to make stuff a lot easier, but it's working there with a wrapper. It does work on Android. I only have an old Android phone to test with, so it does work. It's not quite as smooth as iPhone, but yeah, it's working well.
Could you repeat the question?
Sorry, the question was: is it running in a native wrapper, or is it just a web app? No, but it's running in a native wrapper. Yeah.
Does not load, or so by loading all the pages, does that make it take longer, or is it not?
No, because it's sorry. by loading all the pages, does it take longer to load the app? Because essentially what I'm doing is loading all of the page containers, so we're getting the template ready and not loading any of the content until the first time that we load it. It doesn't take any longer to do it, because essentially a template is just a couple of lines of HTML and some CSS, and everything within that is not loaded until it's needed, and hidden until it's needed, so both those things. I normally, the 4 tabs across the bottom that you would see in the app, so your feed and your profile and things like that, I load those in to start with, just so they're ready. But no, it's very quick.
Other questions for Jamie?
Yeah.
Is it Cordova or?
Cordova, yeah, it's using the, sorry, is it Cordova? Yes, it's using Meteor's built-in build platform, so I'm doing Meteor build to generate the iOS app that I submit to the App Store. Yeah. Oh, sorry.
Actually giving the same performance as the native app?
Is it giving the same performance as a native app? You're getting the performance that I was showing on the screen, which to me is about as close as you can get to native performance without having a native app. Yeah.
We got time for one more question. Yeah, is that, I'm assuming this is built on top of standard Iron router as well, so all your transitions?
I actually built everything on top of FlowRouter, okay. But there's no reason why it couldn't be Iron Router. The reason it's not a package, it's just a demo repo, is because everything is kind of tied together there, and it's not quite as simple as just adding a package. But that's, yeah. But you could easily customize to Iron Router.
Great work.
Thank you.
Thank you, Jamie.
Cool.
All right. Up second on our app showcase tonight, we've got Matthew Jeswell. Matthew is the co-founder and lead developer of Mooch, which is a communication and collaboration platform for college students based in central Los Angeles. Mooch is currently in public beta at several schools in Southern California. Before starting Mooch, Matt spent several years working as a freelance developer and a programming tutor in New York and LA. And his almost non-existent free time, which I'm sure people here are familiar with, he likes to travel, make and listen to music, train for powerlifting, and go on long walks and hikes whenever possible. So, everybody, please give a very warm welcome to Matt.
Cool. Thank you for the intro, Nick. So I wanted to show you guys this thing I'm working on. But first, I was looking out at the audience, and I found myself wondering, how many of you guys are developers that work with Meteor every day? Okay, good chunk of you. How many of you have your own companies or apps? Good chunk of you. Okay, cool. And how many of you are like pre-production or like early stage, still small? Okay, cool, a few of you. All right, great. So that's kind of where we're at. We're calling this our public beta. We're a messaging app for students. You can call us Slack for college students. We call ourselves that sometimes. And yeah, I just kind of wanted to show you the app. And then, actually it's kind of cool that Shawn was talking about the scaling challenges that they had at Classcraft, because we're kind of on the other end of that. So he was talking about after like 18 months of growth, how they've coped with all those, all their new users. We're just getting our first users now. So we're running into problems that we didn't know we had. We figured we were going to have problems, but it's been interesting to see what they are. So I don't have too much to show as far as the app. I mean, you can roll through, you can kind of sign up. So I'm just gonna, I think there's already a few users, so I'm gonna make. And then if you do end up playing with the app, you can go to it at learntomooch.com, and you can actually go on yourself. Eventually, it's going to require a real university email address, but right now you can kind of fake it and get on whatever university you want to. For testing, and like with people who don't go to universities, we usually have them make up mooch.edu email address, and that'll bring you into what we call Mooch University. So yeah, that's it. I'm going to upload a photo. And then it was in. Boom. Okay, cool. So you can get into the app with. Boom. So this is what Mooch looks like. it's about what you expect. You can send messages, you can upload files. We've obviously taken a lot of inspiration from Slack as far as the UI UX. People can post, these sort of discussion-oriented posts, which people can comment on and things like that. Things are pretty much what you would expect with this. We're still building out features. We're getting comments from users all the time, like, "Hey, why doesn't it do this? The way it does this is bad. I don't understand this." A lot of those things have been really interesting. We've retooled the way that things work in the sort of. So actually, at first, we had this idea that if a bunch of people. The first school that we're targeting is the University of Southern California, and I think they have something like 30,000 undergraduates. So we were thinking, if we get a bunch of students from a university on Mooch and they're chatting in this university, this university stream, this university chat, we were thinking it was going to get hectic pretty quickly, and we were trying to figure out ways that we could kind of limit the discussion that was going on in there. At first we had this idea that these sort of discussion-oriented posts were the only thing that you could post in the university stream, kind of creating a barrier to posting a little bit to try and cut down on the volume. And we realized really quickly that that was a bad idea. In general, we realized that we don't want to get in the way of our users. When they see this, they log in, they see this thing, they see this text box, and they want to start typing. So we realized we totally had to let them do that. So that's been interesting, learning what our users want. But really, we've just been sort of learning where the fragile bits are. Since actually getting users, we have had to go in. So we're using Cordova. We've had to go in and look at several of our method calls. And a few of them, you can, when you enable oplogs, Mongo oplogs, you get that nice trace of where all the time is happening, in your method execution. And so some of our queries were just taking an absurdly long time to run. We realized a number of times that we were making queries we didn't need to make, including some expensive ones, and it was interesting to see which ones were actually expensive. It wasn't always the ones that we thought it would be. What else? Just in general, I completely blanked on what I was going to say about method calls. Do you want to?
What are the people talking about?
What are the people they're saying what they want?
No. What are they discussing?
Actually, that's a good question. We can kind of find out. Yeah, let's go scope it out. Am I in? No, I'm in. And actually, hey, we see Nick popped in the other day. Let's get out of here. I think. Cool. So now this is, so actually you see a lot of this is from last semester. So the semester at USC has started relatively recently. And actually, let me see if I can find, what were they called? Was it this? So my partner has been hard at work. No, the only other guy in here is the other developer. My partner's been hard at work getting actual classes onto this thing. I can't remember. No. David Craig, yeah, let's see. Where is this guy? No classes. Okay. So yeah, no, this guy is actually, he's got a couple of his classes on Mooch, but at the moment I can't tell where they are. I think he might have 2 user accounts. So it's we're definitely tightening things up and finding lots of problems as we work with our first users.
Where do you host?
So right now it's hosted on AWS. We use Mongo Lab for our database, but it's interesting to hear about the limitations of AWS and how we're, so the things that Shawn was talking about, I assume we're going to run into those same problems. So it was interesting to hear how they dealt with them by changing away from stock AWS. But that's what we're using at the moment, yeah. There's really nothing too sophisticated going on yet. We've really just gotten this out to users recently. So my partner has had an idea for something in the education space for a little while now, and originally, actually, the idea behind Mooch was more like a Spotify for textbooks or whatever. And you can kind of see like the name Mooch making even more literal sense in that case. Now that idea turned out to be relatively short-lived because in talking to publishers, we realized that they were not going to do business at any numbers that made sense for a small startup. So we had always had the idea of having social features baked in, right? So even when it was based around textbooks, the idea was that students would be able to like share what they were reading, comment on things that other people were reading, things like that. And then we eventually realized that, like, hey, maybe we still have something without the textbooks. Like maybe if we sort of, build these social features, the chat and sharing functionality that, students could find this useful the same way that we find Slack useful every day when we're building this thing. So, yeah, the name just kind of stuck. We just held on to it.
Other
questions?
What's the most challenging thing with Meteor that you found?
Could you repeat the question?
Yeah, sorry. The most challenging thing that we found with working with Meteor, so the Meteor ecosystem's been in a state of flux recently, I think. So when we first started writing, so the code base that we're looking at now started in July, I think. But before that, we'd written a couple, we'd had some false starts. And the first couple were written in Blaze. This was like when Meteor packages were the only way to get dependencies into your app, or at least the only officially sanctioned way of getting dependencies in your app. So no NPM yet or anything, at least not on the client, not that we knew about. So then when we rebuilt this starting in July, we chose React, and I love working with React. So that's been really great. The NPM integration has been improving, but that's still been kind of a rocky road, I think. Like we use Browserify right now to pull in a lot of dependencies, which adds a lot of build time, and that's actually been kind of an error-prone process too, and like trying to figure out exactly how to configure that. Documentation isn't always comprehensive. So I'd say it's just how quickly things are changing, for the most part. Yeah.
We got time for one more question.
Cool.
I saw that you could query for the classes that you are in.
Yeah.
How did you get those classes? Did you scrape the university side? Or?
Yeah. So actually, USC makes it very easy. Oh, sorry. He asked. So we have data for the classes that you can search for your classes, and there's already data pre-populated in there. And asked how we got that. So yeah, we scraped it. So our target schools are all, we just have a few target schools in Southern California, and the main one is the University of Southern California. And they actually are cool. They make all their class schedules available as Excel spreadsheets. And they're all in the course catalog with the same, same formatted file name and things like that, right? So that was actually really easy. But it's interesting you ask, because in the future, we're going to have to deal with, figuring out how to pull this information and then actually where to store it and when to actually pre-populate it. Because right now, actually, we just pulled code that was pre-populating 30,000 classes, which is like a semester's worth of classes at USC, and actually turning them into chats in the app before anybody was even in them. And we realized that was not smart, and that was actually leading to some serious performance problems. So yeah, the class data has been an issue. Yeah.
Thank you very much.
Cool.
All right. Finally tonight, we've got Ahmed Kiarostami. Ahmed has worked in cinema and the cinema and software industries for more than 20 years. After taking on leadership roles at Microsoft Middle East, he founded 3 companies in Iran and 2 companies in the United States, including Naga, the first multimedia and online production venue in Iran, where he published award-winning multimedia products in cinema and visual arts. His last company, Photomoto, was acquired in 2012, and he is now working on his next startup, Quantum. So everybody, please welcome Ahmed.
Thank you. Hello, everyone. Thanks for staying out late.
So Quantum, at Quantum we have several interactive science lessons for kids from kindergarten to 5th grade. The problem, I'm not going to spend a lot of time on this, but you may know that the US is not that great when it comes to education from K to 12, especially in science. And it's not getting any better, even though they're doing a lot of things. And when you look at the problems, there are a lot of things, and you can see that this problem is even harder for regions with high poverty. And when you go to look at people with specific ethnicity background, they are dealing with these issues even more. And there are several studies that show that one of the things that can solve this problem is starting teaching science from earlier stage, from kindergarten or 1st grade. And then in the past few years, they've been talking about blended learning, which is a combination of online education with an instructor there. I have a 5-year-old kid. Back then, she was 3. After I sold my last company, and I was talking to another friend. Now she has a 4-year-old and a 7-year-old. And we were talking about this problem, and we thought we want to do something about it. Unfortunately, unlike Elon Musk, we don't have enough money to create our own school for our children. So we started to look at that from a technical point of view to see what we can do, and we didn't know what we want to do. It wasn't a technical challenge. It was we didn't know what the best way to deal with this problem was. And for that, I looked at a tool that was very easy to develop and very easy to change. And Meteor 2 years ago was still very young, but I found it very, very compelling. And I thought it would be a great tool just to test. And as the idea matured, Meteor matured as well, and now we're using Meteor as our production platform, which is great. We have 4 different components. The admin dashboard, which is our dashboard, we design the lessons. We look at different things in the system. The teacher dashboard, student classroom, and lesson editor. That's something that we use to design our lessons. And I'm going to get that. Like I said, the challenge was not a very technical challenge, but how we would put these things together and how we could change it and test it with kids and get reaction and monitor what they're doing and all of that. I'm going to show you Quantum in real time. So this is our simple standard website. This is the dashboard that teachers see or parents see, that they can add their students or children, and they can see what the kids have done, how long it took to do one of the lessons, if they had any mistakes, challenges or not, all those things. Pretty standard. But in our classroom, this is when the kids log in, and we have because they usually know how to spell their name. You're talking about kindergartens and 1st grades. They know how to spell their name, but they don't know the concept of password. So we have this system for kids to log in, to choose the color that they want, the animal that they want to log in. And after they log in, I'm going to use this is what they see after they log in. I'm going to show you just one quick example of our lessons. Sorry, do we have sound?
We have 5 senses. We can see, hear, touch,
This is to
smell,
teach 5
and
senses
taste.
to kids.
The senses are important because they help us interact with the world around us.
What we
Touch
tried
the
to
kids
avoid
to
was
see how they
having
use their
long
senses.
videos or animations, 15 minutes, 20 minutes, because kids, they get bored. So we have very short little things, and then everything is interactive. For example, this one.
boy loves his kitty. The kitty is soft and furry. Which sense organ is he using to feel the softness? Eyes, tongue, skin, nose, or ears?
So it's very simple, but we have tested with several kids, different kids. When they play with this, they don't need anybody. They can just sit there, start working with it, and they have a lot of fun. Actually, one of the best experiences that I had when I was doing this was testing it on my daughter. I was asking her to do something. I said, if you do it, you're going to get a gift. You're going to get a prize for me. I said, what is it? I said, what do you want it to be? I said, can I do another lesson of this? And that was the best thing. So this is an example. Each lesson has comes in 5 sections, and it's based on a methodology called 5E that they use in NASA. But also Singapore, which is one of the best school systems in the world, is using it for elementary school. So we have adopted that, and we monitor everything that kids do here. And we see how long it took, where they had challenges, where they made mistakes, and all of that. And in our admin dashboard, and these are the schools. We just launched in closed beta, so we have a very limited number of users, 75 schools, 450 students. We're testing it. But you can see our users, you can see who's online, it's just me and my daughter online, but you can see who was online today, who was online yesterday. So we have all this information. And we have a lesson editor. I'm going to use a local copy because I don't want to mess with the server, but we have a local copy of a lesson editor. Everything is fully automated to design the interactive part. And Meteor was a great thing because with the JavaScript libraries that we have used, for example, all the graphics that you see, they are in SVG, so you can use it on a small tablet or big screen, and that's what they use in schools, that they project it on very high resolution screens. Graphic is great, sound is great, and we have developed the whole editor part. We just upload an SVG file, somebody designs all the interactions, and everything works great. So if you have any question, I would be happy to answer. Sure, yes?
Who's generating your lessons?
Who's generating our lessons? We have for the base, we're actually using Singapore's content, but but that's not interactive, they're books. We have a network of teachers. Actually, one in London, one in Canada, and several in America. We're using that, the network of teachers for designing our content. And then we have other steps. Any question? Yes?
Are you imagining students using like a desktop computer to interface with this, or like a tablet touch interface?
So the question is if we're imagining students using a desktop version of this or a tablet. It's actually different when you go to different schools based on the budget of they have. Some of them, even like rich schools for lower grades, they have one big screen, a projector. They don't have tablets for everybody. But as they go up, they have tablets or they have desktops. But the good thing about what we use is you can use it anywhere, from a small tablet to a big desktop to laptop, anything. And I have some videos that of live kids using it in action, but I don't think we have time.
We do have time for more questions if people have those.
Yes.
You talked briefly about animating SVG. What do you do for that?
Yeah. So everything that we do is in SVG, and then we have a sound file. SVG, we have different frames. And you can see in my editor, for example, this is the Kit Kat. These layers, these are different layers that we have in the SVG. So when we load the SVG, you have all the layers, and you have sub-layers. So we have a little...
Somebody is designing an Illustrator exporting?
Yes, so it's just an SVG file. We load the SVG, and we populate this automatically from the SVG file. And then you can...
These are SVG groups or something?
These are SVG groups, yes. Elements that you have, and elements within elements. And then we hide some of those. For example, this one, cat active, you can see that I'm going to make it visible, so you see it here. I hide it. And then we have some very simple things to trigger. When user clicks on it, we play an audio, we put all of our audio, we define all of our audios here. So we upload one audio file, and we define all the segments in the audio file.
Sophisticated things like transitions and stuff?
Every time. So we have all the animations. We have some of the standard animations there. And then for complicated animation, for some of the lessons, because it's only for that one lesson, we have a section that you go and define your animations only for this lesson, and we only load it for this specific lesson. And you can add a specific part of JavaScript that you use for this lesson, because we get more complicated lessons. For example, light and shadow, we want to make things bigger and smaller that you don't have everywhere. So we have small snippets of code that we use. Yeah.
Cool.
Thank you.
We've got time for one more question.
One more question. Yes?
Are you foreseeing teachers building their own lessons?
That's a very good question. The question is, are we foreseeing teachers building their own lessons? Yes. The way we're designing it this way is eventually you want to have a marketplace, basically. So teachers can come design, drag and drop, design their own lessons. And then if other teachers start using that, then they can release the lessons into the market, and other teachers would be able to use it. And if they use it, they get a cut from the revenue. Yes. Thank you.
Thank you very much. Well, thank you everybody here for joining us, and thank you also to our excellent speakers. If you are watching online, please subscribe to be notified of new videos and Meteor Night events. There should be a little button right around here that you can click, and that'll automatically subscribe you. You can rewatch tonight's live stream anytime, and we'll also be posting each talk as its own video. We also upload talks from DevShop London and DevShop New York, so definitely subscribe and keep an eye out for those as well. Our next Meteor Night is Thursday, February 18th. You can RSVP at meetup.com/meteor-sfbay. If you're a member of the meetup group, you probably got an email a few minutes ago about it as well. For those of you here in person, please help us clean up by throwing away one piece of trash and bringing your chair to the back corner over there. We still have plenty of food and drinks, so please feel free to stick around a few more minutes and hang out. Thank you everyone for coming, and we'll look forward to seeing you next time. Thank you very much.